Okay, welcome everyone. We're at the top of the hour, and I think it's time to start. So, welcome to our second Cady Talk. This is where DZS Field CTO Mike Cady has an in-depth conversation about the latest and hottest technology topics and networking connectivity. We are planning on an interactive session today, but we'll be using the Q&A module at the bottom of your screen to take any questions that come in over the course of this discussion with the audience members. Just for your information, we will be recording this and posting it afterwards so you can share with your colleagues. And but beyond that, we're just looking for a robust discussion today. So why don't I go ahead and pass it over to you, Mike, and you can introduce your illustrious guest.
All right. Thank you very much, Jeff. Yeah, and welcome everyone, and thank you for joining. Obviously, as Jeff said, this is our second Cady Talk, and today I have the pleasure of being joined by a new member of the DZS team, Deepak Verma. So Deepak, why don't you take a moment and just kind of introduce yourself and tell us a little bit about your background before we jump in.
Yeah, perfect. Thanks, Mike. And thanks for the opportunity to come and talk to everybody here. So from my perspective, I joined DZS just a little less than 2 months ago. So I've had the pleasure of joining this great team, actually, a great group of people, starting with culture, great place to work with folks. I'm really happy being here. And then from a product point of view, very happy to see the architecture of all the products and everything. So it's been great coming here. From my past experience, started my career back in the B&R Nortel days, but the most relevant experience, I had 19 years at Calix and then years at Radisys. So joined DZS a couple of months ago and looking forward to this conversation.
Yeah, and your new role with DZS, you're running the PLM team, so all the products,
exactly.
So all the products roll up to you.
Yeah.
Yep. Outstanding. Well, happy you're on the team, Deepak, and welcome aboard. So obviously today we're going to be talking more about the evolution of PON and really what drives us to the next level of PON. And this slide, this slide's interesting to me. I think a lot of people have seen, if not this slide, something very similar, where we all understand the drivers or the use cases. You need a lot of bandwidth for some of these new applications, and we also are very concerned about the latency. You have to have very low latency for success with a lot of the newer protocols, and there's even things that we don't know yet of what's coming. But if you start really adding it all up and start dealing with all the different applications, it's kind of overwhelming, the amount of bandwidth and the amount of intensity, latency demands and everything that you're gonna see. But there's a little more to it, and I think what I want to really ask you, Deepak, is when you get into this view is something that I really like because it kind of opens up the Pandora's box of just how many unlimited use cases there are, and you start thinking about not only the amount of bandwidth and the amount of demand you're going to have, but really, what do you see from your point of view of where the drivers are going to be that are really pushing us towards the evolution of the next generation PON?
Yeah, so it's interesting to see, right? So if you think back to previous PON technologies, right? We went from BPON, GPON, XGS PON, now the next generation being 50 gig PON. Right. If you look at all these different applications, all these different colors, what's going to be interesting is all of these are going to be relevant for 50 gig PON. It's really a statement of time of when the service provider is going to need to be able to drive 50 gig PON for these specific applications. But what's going to be really driving 50 gig PON, as I see it right now, there's going to be a couple of different key things. One is enterprise services. I think being able to offer a true 10 gig symmetrical service has always been something that I've been hearing from service providers that they want to be able to offer. And then obviously even more than that with 20 gig symmetrical. XGS PON, as we know, is a 10 gig PON technology, but with all the overhead and forward error correction, it's a little bit less than 10 gig PON. So enterprise services is going to be one of the key drivers. The other driver, as I'm hearing from some customers, is really service providers who are looking to be market disruptors and shift their investment, even for residential services, to 50 gig PON. and offering higher tier services. Some of them, like, I've heard an interesting, term, fiber to the billboard, really trying from a marketing
Yeah.
perspective. Mike said that to me, and it really caught on, right? It's really trying to be creating that buzz around a higher tier services than the service providers competitors, right? So
Well, and that's what's so great about PON technology and the fiber technology is because you can still have GPON in your network serving your residential customers that only want 100 meg or even a gig service. You can still have XGS PON in there for the masses, but then you do have the ability to overlay or coexist with the existing PON technologies to offer that fiber to the billboard. And that might be what it is for the first year or two as we deploy here, really having that market differentiator. But being able to be ready for all these applications, I think, is really, all the emerging technologies and the VR, AR based stuff with the latency demands. But really, you get into the healthcare and just the thought of remote surgery and things like that of how critical that is. And in the mobile applications as well. So, I think it's really exciting, but I think it's important to remember that the GPON and the XGS PON that you're deploying today doesn't have to go away. It just can be an add-on, at least for the foreseeable future. So,
yes. Yeah, no, and the other key thing with 50 gig PON from an application point of view is the fact that being able to eliminate the number of queuing points and everything like this and
right.
bringing in low latency into the solution, right? So like, yeah, Mike, you talked about healthcare. That obviously is so key and critical, latency and, different remote surgeries or anything like that as we look at future applications. But, the AR, VR, applications are going to latency as well, autonomous driving. There's a number of different applications that are going to be driving us towards 50 gig PON, and the infrastructure is there. That's really the key thing.
Well, and you touched on it. The infrastructure for the PON part needs to be there, and that's where we're talking about today.
Yeah.
With the ability to have the XGS coexist with the other services, but we can't forget about the middle mile. We can't forget about the transport part of the network itself. And I know today we're really talking about PON, but we have to remember, you take all that PON traffic, you take all that fiber traffic from the residential and business and enterprise and the medicine and healthcare. You bring all that together, we still have to have the ability to transport it with a low latency capability. So that's where products like the Sabre family fit right in to help with that transport piece of it. But that's not today's topic, so we'll talk about that in an upcoming Cady talk. But for today, I wanted to kind of take this to another step here, go into the next piece of this where you start thinking of the evolution of PON, and why it's important, because we've all talked about this before. We've seen the standards, going back to BPON days and GPON, and then there's all the other various substandards and everything. But talk about this a little bit, Deepak, if you don't mind. I'd like to kind of get your thoughts on why this is important.
Yeah, so why it's important, and again, starting with I think I'm missing one even with APON that
Yeah,
I was there before
exactly.
that. But as things have evolved, right? We can't imagine the type of bandwidth that going back a number of years. Every single step that we've taken has been a significant amount of bandwidth, from an access point of view and from an oversubscription point of view, that you're sending traffic to residential subscribers. But primarily PON has been used for residential services. And as things have evolved, as the standards have evolved with XGS PON, there's more and more enterprise services that are being put on XGS PON. But from another application point of view, being able to do mobile backhaul on 50 gig PON becomes real, right?
Yeah.
So from a convergence point of view, having this increased bandwidth enables that convergence that's going to help customers improve their operational expense. Instead of managing a single network for all their different services. So that's really key. But the thing that impresses me the most is the work the standard bodies have done, and the work that they've done to ensure the coexistence of all these different technologies. So if we just center on GPON, XGS PON, and 50 gig PON, these can all coexist. So as folks know, I think I've heard numbers like 80% of the cost of deploying a PON network is in the infrastructure, right? The infrastructure
Production, the fiber, the
and all
splicing,
that.
yeah.
Yeah. So, the fact that a lot of customers have made that investment in the infrastructure, electronics associated with, XGS PON, 50 gig PON is really minimal compared to what all the costs they've incurred in the past. So the investments that they have made in fiber is really coming, and paying off for them, right? And being able to evolve to 50 gig PON becomes a lot more trivial.
Well, and maybe just to clarify for some, what we mean by the ability to coexist is really we're using different wavelengths on each of these applications, and by using the filters, we're able to layer those wavelengths on top of each other on the same fiber ODN. So, and that also gets back to another point of this is, for BPON, GPON, everybody, 32-way split was really common for GPON. Some tried 64. I've heard, we've had some 128s out there, but that's really kind of splitting that bandwidth up. You get an XGS PON. Now people are looking, 32, maybe stay 32 and get more bandwidth. But then some are going to 64. And now you start talking 50 gig PON, and now we're really getting to the ability to maybe even do additional split. We have to keep in mind, we've got our distance, power budget we have to worry about, and the cost of the cost of the additional splitters within the power budget to make sure that we can meet those demands. But what are you seeing in the industry as far as where people are headed with not only XGS PON, but into 50 gig with the amount of
Yeah.
nature?
So what I've seen is, again, as you mentioned, Mike, GPON 32-way split. For the most part, customers, depending on the region and the bandwidth demands from customers,
Right.
predominantly 32-way split has been used for GPON. For XGS PON, I've seen predominantly 64-way split, and some cases 128, and then 50 gig. Yeah, I imagine that it's going to 128-way splits and maybe even 256-way splits. So I see that being a factor. And then the other part of it is, the optic vendors are going to play a key role in this as well with 50 gig. The state of the optics, there's different form factors of QSFP and also SFP-DD investments that are being made. But the way I'm seeing it right now, the optics are 50 gig by 25 gig, but very quickly they're going to become 50 gig by 50 gig. So if you see with the 50 gig PON, there's really 3 different options. And, there's an asymmetric options with 12.5 gig upstream, 25 gig upstream, or there is a symmetrical option with 50 gig by 50 gig. You can imagine the factors that are going to play into this is one from a technology point of view. The other part of it is going to be cost. The cheapest is going to be the 50 by 12.5, and the more expensive is going to be 50 gig by 50 gig until the adoption curve plays in and drives the price down.
It's the other part of this really comes back to the modeling, going back to the use cases. And I think your split ratio and how you deploy is going to really depend on what your use cases are. Because if you're only thinking, you're going to deploy 50 gig PON for mobile backhaul or something in that nature, then maybe you aren't going to do a higher split because you're going to dedicate that bandwidth to those services. But if you're starting to do the more residential play or MDUs or things like that, then maybe your split can be a bit higher, just like it was with PON, and again, and I think one thing that kind of changed things is when the less and less IPTV, more and more over the top, I think that kind of changed how much bandwidth was required within dedicated to a PON network as well, too. So, well, that's all interesting. And I think the key is the fact that once the fiber's in the ground, we have the path to evolve it without having to change that infrastructure, which is critically important. And it's also important when you start thinking about your next deployment model, your OLTs that you're deploying today, PON, XGS PON, mix match, whatever it might be. You have the ability to migrate into the next piece. And that could be as simple as, adding another box with a coexisting element, or it could be slotting a card. Talk a little bit about this, Deepak. I'm interested to get your opinion on the different ways of deployment.
Yeah, so what's going to be interesting, and I see a lot of, if we talk through the different scenarios, scenario one, where a service provider adds 50 gig PON onto an existing network. It could be a total greenfield and they decide to go 50 gig right from the get-go, or it could be that they've got existing deployments. And from a overlay point of view, and as Mike talked about a little bit earlier, there's a concept of coexistence of the different wavelengths of the technologies, GPON wavelengths, XGS-PON wavelengths, and 50 gig PON wavelengths, all coexisting on a single fiber going out to the subscribers. So with that capability of coexistence, I see a number of customers, especially because 50 gig PON initially is going to be a point service technology in a lot of cases. So as an example, a service provider wants to deploy enterprise services over the same ODN, optical distribution network. So in that case, I could see a small form factor 50 gig PON solution coexisting with their existing deployment, have a coexistence element, take in those different wavelengths, and then shoot it out to the PON tree, right? So that's going to be one scenario that I see. The other scenario is like a brownfield. Hey, I want to migrate to a 50 gig PON chassis because not all chassis today can support the evolution to 50 gig PON. So there's going to be cases where a customer wants to be able to upgrade to a 50 gig PON chassis. And as part of that, they don't want to interrupt their existing customers. So this tri-band coexistence optics are being worked on as well, where it has very similar to the combo PON optics today that have GPON and XGS-PON. We're going to see GPON, XGS-PON, and 50 gig PON optics that can coexist on without the need of an external coexistence element. So
right, and that'll help with the power budget on your ODN.
Yeah.
It'll also allow you to maintain your GPON ONTs and your XGS PON ONTs that are maybe in the field, but
Yeah.
also going to allow you to put 50 gig right on top of it as well.
Yeah.
And then of
And
course the dual band.
You hit on a great point, Mike. The scenario of keep your ONTs out there. This is where, from a vendor point of view, DZS, one thing that I really like is we embrace open
Absolutely.
standards, right? So we have a significant number of third-party ONTs that we can interoperate with, right? And for a customer looking to, the practicality of going out there and ripping out ONTs from a home is very operationally difficult.
Yeah, and expensive. Truck roll costs of that alone, it can ruin your ROI for a year.
Exactly.
Or more.
Yeah, exactly. So that coexistence or that interoperability is very important. And then, so I see tri-band being the brownfield scenario in a lot of scenarios. And then very similarly, dual band optics. So from an optics point of view, again, you've got 50 gig PON only optics. You've got 50 gig dual band that can coexist with either GPON or XGS PON.
Right.
And you got tri-band, which can coexist with all three, right? So obviously, the more coexistence, the higher the cost of the optics is going to be. But there's also going to be scenarios like customers already upgraded to XGS PON, as an example.
Right.
Their whole network. So dual band optics is going to come into play. Again, no need for external coexistence element. Including DZS, have supported the ability for multiple PON technologies on a single physical port.
Yeah, and in that case, what you just mentioned with the XGS PON, and then you don't need the GPON PC.
Yeah,
the dual band, and then that gets into kind of the different scenarios as well. You talk about the smaller form factor, maybe a 2RU chassis with a 50 gig, and that could even be coexisting with an existing OLT, or if you happen to have an OLT that supports 50 gig, which we have with our 6 slot and our 14 and our 2 slot, you could simply slide the new card in, and whether you're able to use it at coexisting element or your new ODM or roll your customers over. But the key is you're not replacing your chassis, and you're not replacing your fiber infrastructure. So talk a little bit about your portfolio. I know coming over,
yeah.
This is pretty exciting because we have the full gamut of products, but just take a minute. I know we don't want to get too deep into all of it, but kind of highlight what you love here.
Yeah, honestly, this is one of the things that I've loved about the DZS OLT portfolio. If from a couple of different things. One is from a form factor point of view, depending on the point in the network that you're trying to deploy in. We range from the fixed form factors, 2 slot, 6 slot, all the way up to high density chassis. The other key things that I love about the product is one is line cards can fit in any of these chassis. So you're not limited. So if you are a service provider that can deploy different areas, different density needs and everything like this, from an inventory point of view, the line cards are the same. So that's one thing that I really appreciated. The other part of it that I really appreciated was the NNI aspect of it. So the way the hardware has been designed has been designed from a disaggregated hardware approach. So again, you see chassis, but it's also there's a disaggregation associated with it. And if you look at this, there's the physical PON ports that you see on the top of the line.
Right.
The other part of it is you see the QSFP DD interfaces on the bottom. So the thing I really like is that there's an ability to send the traffic out the front panel if you want all that extra bandwidth, or you can send the traffic via the backplane to the fabric card going over a common network interface through the fabric card.
Right, right. So you can use if you're in a chassis infrastructure, you can send your mass traffic, your residential PON, your normal traffic across the backplane, out your fabric card, your uplink like you normally would, have your redundancy, have all the capabilities there. But then if you did want, like emphasize what Deepak was saying, you could bring your traffic in and actually exit right off of the card itself, have a system on a blade, if you will. So this slide, I think, is something that's interesting because I really want to, without taking too much more time talking about the rest, getting into the fact that not only with the evolution of PON, we also have evolution of some of our chips. And being a Broadcom partner, we have the ability to bring in some of the new, Lotus chips and some of the new features. So talk a little bit about the advantages. Not only, I'm kind of stealing your thunder here, but talking about the neural engine is exciting, but also what about the power savings and the advances there?
Yeah, so one thing that Broadcom has done that's pretty interesting is the typical hardware architecture has been having one piece of it is that there's the PON MAC, the portion of the card that will talk the PON interfaces out to the subscribers. And then there's typically an aggregation point, a switch that aggregates these different PON MAC chips into the common switch, right? And from a solution point of view, that has historically a lot of different architectures from the different vendors. What's interesting about the Lotus chip is that they've combined those functions of the PON MAC plus the switch into a single one. And why is that important for us? One, as part of any evolution, they've increased the density. So the number of PON interfaces has increased, doubled, in fact, as well as supporting 50 gig PON. But also by combining these chips, the power savings that come along with that is going to be pretty significant. We're looking at potential 30 to 40% power savings with that combination. So, we'll obviously be putting it through its tests, but that's the anticipated power savings that come along with, the combination of the PON MAC plus the switch into a single sock. So that is one aspect that's pretty cool. And then as you touched on, Mike, the integrated machine learning and AI processor that comes along with this. This is something that's going to be very important for a couple of different reasons. One is, we're going to have access to a significant amount of information that's based on traffic flows, based on, what the subscribers are doing, everything like that. So one, this data can be pushed to a common area in the cloud. That's one option, but there's also some in-chip processing, in-chip actions that can be done that come along with this as well. So very excited about the neural engine that's going to be coming along with this, and the steps that we can take to, better improve the operations, better improve the robustness of the system, and take some proactive actions, right? Versus having to have a technician go and take some action based on some event, right? We really need to get to a system that's continually running and acting on its own. So
Optimize.
really
Yeah.
excited about that.
So I know the question that everyone's going to be asking is when? When is 50 gig going to be deployed? And I know there are some advancements in the network, there are things that are happening globally, but we also feel that the need and the demand for it isn't quite there yet for the market either. So there's going to be a market evolution here as well. But when will we be ready to demonstrate? When will we be ready to deploy? And I know we're anxious, but at the same time, just wanted to get your thoughts on that.
Yeah, of course. So we're targeting third quarter of this coming year for
Okay.
having the 50 gig PON solution. So again, this will be a line card that can fit in our chassis.
Okay, perfect.
Yeah.
And then, I think one of the things that we wanted to kind of close up here on before we get into any questions is, and these are kind of a little bit of a recap of what we talked about earlier, but one of the key things is the open standards, the ability for DZS to be able to support your evolution, whether you're deploying, GPON, XGS-PON like we talked, or moving into the next gen scenario. You might be capped out. You might have your OLT already built out with XGS and you want to move to 50 gig, then we can slide in a 2RU, for example, right with it and use coexisting elements. Or maybe you've got your ODN, you got your ONTs out in the field, but with our abilities with the open standards, we can replace that OLT and connect right to those ONTs and save you that truck roll. But there's also the multi-vendor orchestration part of it as well. And with our Extreme platform, and we'll talk about that in an upcoming Cady talk as well. But with the Extreme platform, we have the ability to orchestrate SDN control multiple different applications at the same time as well. And Deepak, I'm stealing a little bit of your thunder again, but you talked earlier about the chassis flexibility. Obviously there's pros and cons to every different deployment model. But once you deploy a chassis and it's powered up and it's wired up and you got your fabric cards connected to your core, your uplink is set, it's pretty easy to slot a new card.
Yeah.
And I think that's a huge advantage, especially when you're dealing with, multiple different groups in your organization. You might have to have certain contractors or certain people that can do the power, and installing a new 1U could actually be quite expensive or time consuming. So there's a lot of advantages to it, but again, we support both models. So it kind of whatever fits in your capacity there. So what else would you like to highlight real quick here before we look to any questions?
Yeah. So just a quick summary, and you hit the key points, which is awesome. Just a couple of just additions. One is you need to look at your current, as a service provider, you need to look at the current deployments you have. One is, does your chassis, does your system have the capacity not just to support, for 50 gig PON interfaces as an example, but can it support high density 50 gig PON? And that's what's going to be important, not necessarily for right now,
Right.
Because I see a lot of overlay type scenarios where potentially 4 or 8 are going to be important. But as you look forward, can your system really support high density 16 port 50 gig PON interfaces as an example, right? So that's the type of thing that you want to look at, not only from can you physically put it in, can it cool it from a thermal point of view, and can you get the bandwidth out that you're going to need for that's one key thing, and
can you transport it, like we mentioned earlier? Can
exactly
you get it to the next part of your network or to your off ramp? So that's a key piece of it too. Absolutely.
Yeah. So a number of different factors that play in, and again, you just need to be thinking of that evolution, right? And the beauty is the standards body have done the work, and the most important investment has been made in a lot of cases for fiber. It's the electronics can be overlaid on top of it, which is great.
Absolutely.